Hello, everyone. Thank you for joining us today in the last Rhino User Webinar of this year. I am Guillermo Varela from Magni Europe. I am here with Eliana Nigro. Eliana is an architect and educator, head of computational design at Cobe, and founder of ELNI Studio. And today she will show us how computational design can make the design process smarter, faster, and more creative. And we will look at real examples of how data algorithms and automation are used to make better design decisions, tackle complex challenges, and free up time from repetitive tasks. Remember that in the last 15 minutes of the webinar, or a bit less, maybe today, we will have some time for Q&A, so you can ask questions in the chat and we will check them at the end. Also, I would like to mention that the webinar is being recorded as always, and we will upload it to our YouTube channel tomorrow, and you will receive an email with the recording link when it's available. So don't worry about that. Thanks again, Eliana, for accepting the invitation, and you can start with the presentation when you're ready.
Okay. So, hello everyone. I wasn't expecting so many people, so it's really a pleasure and also amazing to, get to present at a Rhino user meeting. I'm very excited. So I'll start by sharing my screen. All right. Perfect. So you can already see, like, you have already a bit of a spoiler. Just let me know if you can see my screen. Is it okay? Yeah?
Yes,
Okay,
not
perfect.
maximize, but yeah, now it's
Okay,
perfect.
great. Here we
Thank you.
go. Okay, so you already said something about me, so that's great. And today we are going to talk about designing with the data. But before diving into the nerdy stuff, I want to tell you just a tiny bit about who Kobe is, because part of the digital approach is actually reflecting what we believe in, so what our values are. So, who Kobe is in a few numbers, and I promise this is going to be very short. So, we are an international hub of around 170 people. The company is quite young, born in 2006. But despite that, we work all over the world in different scales, and our build projects are in more than 10 different countries. So, we are located, as you can see down there, in Copenhagen, more specifically in Nordhavn, which is a place that is very close to our heart since we designed this entire part of the city. So we can say that we are in a one-to-one laboratory. We are literally on a construction site, and around us there are so many spin-off projects that we made. Some of them are quite famous, like the silo. But what truly matters here is to understand that we actually wanted to test what we designed. We wanted to understand if our vision was true, or we wanted to learn from our mistakes. That speaks volumes about Kobe. And going back to our office, you can already understand by this space a bit what we believe in. So on the left, you can see how the building used to look like. It is an industrial building, an old warehouse. And we actually, on the right, you can see that we preserved those historical traces. We kept all the massive, beautiful steel columns and the concrete beams. And at the center is actually where I am right now today. In I can see that there is also like some sort of tour going around. We have many people coming and visit the office. And these meeting rooms, they actually don't reach the ceiling. So they look very playful. So here you can understand that when we work in any context, we want to be respectful. We want to be rooted in that reality, but at the same time, bring something different in. For example, at our office, we have a cafe, and you wonder, why are you talking about a cafe? I'm not sponsoring that. We don't get money for that. It's just to say that we want every time, even if it's just an intimate private office, to have the public come in. So to create an attractor and to really create the change. We don't work only with architecture, we work also with urbanism and landscape. And if you look at our portfolio, it's actually much wider. So we also do infrastructure, for example, a lot of bridges and stuff like that. And going closer to computational design, we want to be future proof. So we want our designs to be long lasting, durable. And if you think of working in a smart way with scripts, what's a better future proof workflow? I mean, you are basically reusing some parts and you're working like faster, efficiently. And I'm gonna show you some of these things. So here at Kobe, I'm as said, the head of computational design. That means that I am doing all the planning, the development, integration, knowledge sharing of computational methods. One thing that we truly focus on is automation. So we want to remove as much as possible all the repetitive machine-like tasks. So we don't want to sit and do a lot of heavy clicks, but we want designers to do what they can do best, which is focusing on creativity, on strategy, and truly coming out with the best solution possible. Of course, it's not just about repetition, but even more importantly, about understanding what we are doing. So every time we work, doesn't matter what it is, doesn't matter the scale, we extract the information we need. So we make sure that we are on target for our clients, but also and even more importantly, that we are meeting our sustainability goals. So we constantly look at the qualities, so the aesthetics, but also at the quantities. And I mean, that's so powerful because when you communicate with numbers, the guesswork gets out of the equation. And that means that even if we work across different disciplines and we don't have to go to style, we do have a large portion of tools that can help us with, for example, simulations. Like in this case, we are looking at the sunlight analysis with Ladybug. I mean, doing all these things actually allows you to be a bit more certain about what you are coming out with, about your ideas. You can truly, in this way, make sure that you're leaving a positive mark on society. And what we do here at Kobe with computational methods is always making sure that our tools are very intuitive. So we build interfaces. About that, I don't care of sometimes sitting with the people and actually understanding what's the way they want to work, what's the way they get creative, because the tools should truly reflect that. So sometimes maybe we change the inputs or we change the interface so people can feel comfortable. And that at Kobe is even more important because again, we don't have to go to style. We have many different disciplines. That means that us as computational designers, we want to get all that knowledge. We want these people to give a feedback. We want them to come back with new ideas. And that's really precious to create a toolbox that can have an impact on the large scale. So we can truly play around and make sure that we finalize what's best. I just want to say in a small parenthesis that even if I'm so much in the digital process, I do believe, and Kobe believes, that the physical world is equally important. So we do a lot of models and we bring them in the room. We look at it as a team. And I mean, we can cut it and glue it back together. And that's quite interesting to see. It's a different way of being creative. And then, we can take that knowledge and build a new 3D model. We also explore AI solutions. We also believe that some solutions out there are actually very good to spark new ideas or to test out some design solutions a bit more quickly. We are actually very open-minded, and we do know that how the toolbar of the architects look at the moment is actually ever changing. And we are integrating AI also for expressing some abstract concept a bit more clearly. So just to say that what you are going to look at today is just a tiny part of what we are doing. And now I'm going to switch to this other presentation because we are going to dive specifically into one project. So I'm actually doing something I think quite unusual because I'm not presenting a sexy, complex shape. I'm going for urbanism. So I decided to present a project I love very much. We won it recently, very proud of it. It's located in Hamburg. It is actually an entire district by the park that combines different functions. I will not dive in anything related to the design. We have a fantastic website. You can check it out. I'm just going to talk about the BIM challenge that we faced for this project. Because since the very beginning, with the first phase of the competition, the client wanted us to deliver IFC models that were incredibly detailed. So in this case, we are working not only with buildings, but also with the landscape. And the IFC is not just made by dumb geometries, but all of them are proper BIM geometries with a lot of attributes attached. So how do you nail that in a very limited time and with such a scale? We are talking about 55 hectares of terrain to design and 630 more thousand square meters of buildings. Just to make it a bit more clear, we have more than 300 unique buildings. That's a lot. That's a lot to, design, to think about, and even to deliver with such a precision. To make you grasp the amount of quantities that we needed to extract, you can look at this. This is the Excel that comes out of our IFC. So there is truly a lot going on. And this, I have to say, wasn't just thanks to computational design, but also the fact that there was an amazing teamwork. So we were quite a tight team when we started. And we truly, since the very beginning, talked about what made people comfortable, how they wanted to work. So what the inputs should be. Therefore, they could focus on creativity and we could handle the very last part, the digital delivery, just in the last few days. So how did we do that for something so large? I want to make a small parenthesis again, just to say that, we work very often with these numbers. This is on the right, Jennevanebyen, another very famous project of ours, district in Copenhagen. It has even a higher density. So we are used to deal with this scale. And every time while we work in real time, we need to know the quantities. For example, in this case, you can see, and this is just something super simple, it's just areas by function, but it is important for us to know what is the amount by neighborhood or by plot. So we are used to have this information on our screen. So even if we are working with just one building, very, very simple, we can just feel free to play around. And even if we do drastic mass modification, we can immediately see what that means and if we are on target. Even more interesting, we can see if we are out of a certain envelope. We can do the famous one-to-one projection of the facade down in real time. We can do all the floor plates. And what I love the most is that you can, within the same script, integrate also simulations. So while you are working, you are actually able to see, for example, like in this case, am I creating shadow in the courtyard? And where is that? And if I do this, what happens? So you're able to evaluate and in a very simple way, just move in the best direction possible and also justify to our client why you took certain decision, why a certain shape is better than the other. We also use these methods to do some generative design. So sometimes we run optimization just to also ask to algorithms to give us some guidelines. But we usually prefer an hybrid approach. So we usually do our massings in Rhino, so everyone can do that freely. And we have scripts that run in the background that give you information regarding the geometry itself. Like in this case, you can see total area, floor, maximum height, but you can also see, in this case again, dark areas or average sunlight. And you can see that we always integrate also the context because we want to be respectful towards the public spaces, towards our neighbors. So that's very important to us. So we wanted all of that for this gigantic project. And we didn't want to worry about doing an IFC model at the end. So we wanted that intelligent flexibility. We wanted to make sure to have clever solutions and optimize right from the start. So there was a clash between the flexibility we wanted and the precision of those IFC models. We do know from some of our competitors that they had to stop a month earlier and just spend an entire month and a full team of brains to produce these detailed BIM models. Instead, we decided to do something different. So we used machines to do this process. And then our designers could go out, meet with the city, meet with the people that are gonna actually inhabit those spaces and take notes and actually change the design according to that. So it is extremely important that we utilize the right technology in order for make the best decision possible. Otherwise, sometimes we don't have the time. So there was this digital dilemma. And as said, we met as a team and we decided we wanted to save resources. We wanted to automate as many repetitive tasks as possible. On the other side, we wanted a smart flexibility. So we wanted these scripts to run in the background and to always tell us the important quantities. And all of these we want it to be easy, so easy to use. And if you look at the layer structure that we used at the beginning in the first phase, I mean, there is nothing special there. It's just as many people do, just the functions. And from that on, we were able to actually create something much more complex. I mean, we were able to keep in consideration all the targets that we needed to meet for the landscape and for the build program. And if you look at the breakdown, I mean, that's insane. And it's not just about square meters, it's about footprints, it's about floor to floor heights, about amount of floors, and so much more. So let's dive right into it. So the concept is every time we work, we visualize the quantities. Every time we work, we visualize percentages. I mean, if you think of a large scale, in this case is an example on Bromview, which is another project of ours, is it truly a lot and also quite overwhelming. And honestly, it is insane what our designers can do. Going closer to it, going to the first IFC, I want to start with my favorite and also the easiest, which is the landscape and the topography. So the client was great. They actually provided us some detailed IFC models, for example, of the existing terrain. So immediately we met as a team and we could analyze how the terrain would work. So what are the contour curves? What are the different heights? And you wonder, why is that important? Why do you need to look at the different heights? Why do you need to look at the slope? Again, we are a team of with different expertise. So what is clear to a landscape architect just by looking at numbers, it might not be clear for an architect. So this is a very simple coloring of meshes. I mean, it's very useful. So we can immediately tell which areas are quite difficult. So maybe how we should orient our buildings, and also how the water is flowing. And if you know how the water moves, then you can think of what would make sense to have as a green corridor. And then you can understand how your streets should go. And that is already informing your design choice, is already creating some sort of infrastructure for you. Then since we were all on board with knowing all this information, we created a script that could allow us to change the terrain very, very quickly. So let me run this again. So here it is, the original terrain. Here it gets modified, and again, it gets optimized when looking at the floor plate of the buildings. Okay, let me phrase that again much better. So basically what we did, since we were always changing the shape of the plots, we were always changing the location of the buildings, we created a script that could allow us to basically plug any sort of shape for our buildings and understand what would be the best location of them on the terrain, and create a flat surface underneath those buildings. So the terrain modifications would be as little as possible. So we could save up also in that case in terms of sustainability, because it takes energy to move terrain and so on and so forth. Of course, this again was teamwork and a lot of thoughts in terms of like landscape and buildings. The easiest part, honestly, as I said, is transitioning from Rhino to Revit at topography. Who works with Rhino Inside, I mean, knows is just one component. So if you have a good mesh, it is very simple to bring it through. And we do that in many projects. This is another project of ours. You can see that the terrain is quite detailed. And I mean, to bring that into Revit, it is very simple. What is not easy is actually all the other attributes. But just to say that we had easy time with the topography, also because we work as an office a lot of on landscape. So we are, oh, something bad is happening. Let me restart. Okay. So finally, we can see it. So as an office, we are used to do terrain manipulation, starting from different inputs. In the case of Volkspark, it was a mesh, sometimes some quotes and the buildings. In other cases is points in the space, is quotes. It's really different according to what makes the most sense. But what we care of is, again, keeping the terrain flexible and not having to worry about modeling in 3D, and actually having all the instances related to the terrain that just follow, such as the trees or the buildings. So we could just, focus on making the good strategies, and then we didn't have to worry about modeling the topography or placing the trees on the terrain or projecting the buildings. About the vegetation, the client also provided us with a lot of trees, and all of them coming from an IFC model had a lot of properties attached. As a team, we thought it wasn't very comfortable to work with these 3D. So what we did was to move all of them into Rhino, and we actually decided to translate those into 2D blocks. And the 2D blocks would just carry some of the most important properties, such as the radius of the canopy, because it was important to us to count the amount of trees according for each category, each size. So also the landscape architects could have those information in their hands, also because we had targets for that too. So it was important to have also this information out and nail them in, again, a super simple way, because again, the topography just comes out in a click. And then as soon as you move your 2D blocks around in Rhino, they will just be changed automatically in your synchronized Revit version. But there is much more than terrain and trees. I mean, there is a proper landscape design. Design like this, very, very precise. And we wanted to reach the same level that we usually do in other competitions. So we actually were able to detail a lot. And it is, again, very fast to transfer the geometries through. What is not easy is to attach all the attributes we needed. To understand what kind of attributes and information the client wanted from us, you need to know that there are different phases, there are different neighbors, different plots. And if you think of the landscape, then you have different levels of permeability, you have different materials, you have different categories, subcategories, functions, so on and so forth. A lot of things for just, one tiny piece of land. So, I mean, each of these tiny pieces. So this is a very ugly snip that I took while we were working on our first days. So here you can see in under others some of the data that we had to fill. So it is easy to bring the geometries through, but then it is not easy actually to give this information. We needed to assign the right material, and again, permeability, the function, and this is work in progress, as you can see. So we didn't have all of them yet. If you think of doing this work manually, we are talking about thousands and thousands and thousands of these tiny geometries. So think of having a person selecting them and do that work manually is just insane. It takes a long time. And also a person can do that job wrong because you can get confused and just type the wrong, for example, the wrong face in. And the worst part is that this type of workflow is not flexible. So, it takes so long that you don't have the time to change. So what we decided was that, as I said, the landscape architect would focus on just designing, and then all the attributes and geometries would come by itself. So this is the machine that is behind. For you to know, I work a lot with the data trees. So everything that you see here is actually necessary. Nothing is repeated. On one side, we do have everything that is allowing us that smart flexibility. So being able to read all the data to make sure that we are on target. And then we are taking this data and transferring them into Revit with Rhino inside. And again, it just takes seconds, even if we are talking, again, about 55 hectares. So we are talking a second against a month of like a team working full-time on such a task. Why should we put people on doing something that can be automated? That's like a huge waste of talents. So this is, for example, how our Rhino would look like. All the colors would be for the different functions. Of course, as a designer, you need to choose what function you want, but then all the rest would come by itself. The script very easily would understand in which phase that piece would be, so which phase would belong to. It would understand if it is a private or public piece of land, and if it is actually private, to which plot it belongs to. So we could save time on just all these things and just feel free of modifying stuff as many times as we want. And if we look at the buildings, it is much more complex than that. And you can see that we actually got to an extremely high level for the buildings because we could actually focus also on their facade expression, for example. So just by looking at their volumes, we tested many, many things out. So here you see just one of our options and just one building. So you can see the first part of the script in action. So we are able to read the layers, super easy. Then we are able to read all the different floors, even if this is located on the terrain. So because the client wanted us to specify the different levels, and then we can understand to which plot and whatsoever, every stuff that I already said. So if we look at our generated Revit, you can see that here we are querying the attributes with the Rhino inside. We can read all these 10 attributes for each of these geometries, and verify that they are assigned correctly. For example, we also needed to specify, all those unique 300 buildings. And this is, for example, how it looks like with all the slabs, all the walls, all the roofs. And you can see that for each of the geometries, all the data are assigned. And those buildings are placed on the topography. So, I mean, think of the landscape team working, the urban team working. I mean, and then like having to place these buildings correctly on the terrain. Of course, also that was automated. So in a click, you would modify the topography, and also all the newest buildings would be placed on the terrain. We would have the same layer structure. And then you can see like in the bottom, then just we have some guidelines for the faces and the plots. So when we do that, also in Revit, all the levels are automatically generated. I mean, the client had a lot of specifications on how they wanted the things to be modeled, and all the slabs supposed to be on the correct level and then named according to the specific building, the the plot and the face. So it was actually a lot of work and extremely convenient to have a machine running all of that for us. And of course, we don't trust machines 100%. So we also created some other scripts to make sure that we could visualize those parameters. So again, querying all the parameters and making sure also, if you're not a grasshopper expert, that everything is perfectly aligned. Actually, this is because now we are developing more the design. This is one of our latest design, and we are just looking at one of many options that we are providing to the client for just one plot. So we had a lot of automation also when it comes to visualization by parameter, both in Rhino and in Revit. And we do move from Rhino and Revit very often, especially when we want to do design studies, just because it is much more comfortable for us. We find it much more dynamic and, very flexible. So we actually use a lot the scripts to just go back and forth. And as said, we actually reached a very, very high level of detail for this project. So we do have scripts that enable us to go from just a volume to a facade. And we do that by auto-generating blocks around the volumes. And it is comfortable to us to go back and forth also because these simple volumes can be easily brought into reality as physical models, but they can also be used for simulations. So when we think of simulations, I mean, there were requirements for that. So the client wanted us to think of the microclimate strategy. So we actually did a lot of simulations. And again, that is relevant for us. If we look again at Jennevanepyr, the project that I mentioned before, it is again more or less the same size. And we were constantly analyzing how the facade would, what amount of light they would receive, because we needed to make sure that, for example, we wouldn't have apartments that wouldn't receive any direct light. So very early on, in the early phases, even if we are doing an urban vision, I mean, we need to set the things right. We need to set the right constraints for people to then have the best indoor and outdoor conditions. We don't look only at the sun, we also run many other simulations at the same time. For example, in this case, we are back to that tower that we were looking at the beginning. this is a project in London. And as before that, you could see, area, floors, maximum height, and everything related to the sunlight. We also analyze the view to a specific attractor or the view to the sky. And we utilize those data not only to shape our buildings, so to decide, which massing would work the best, but also for the envelopes. So we can use those information and then standardize the facade and create different facade panels according to what is needed. And this is a strategy that, we have been using for decades, and it's been there out in the parametric world for very long. So it is not new, but we do that very often, even if we are just looking at the large scale and not as something detailed as one building. And we look simultaneously at the outside and the inside. But when I said a decade, if you think about where Tip of Red Molen, this is a competition from 2015. It was recently finished. And the concept is the same. You do have the facade that is basically following the sun path. In this case, you don't have so many context around, so it was easier to standardize. And standardizing is also important when you think of fabrication. So we try to do that as early as possible. And standardizing also means that when we are dealing maybe with more unconventional shapes, we actually try to simplify that. Like in this case, this is a project called Europa Campus. We were actually making sure that each of the elements would be a perfect arch, so a perfect piece of a circle, so that we could control it much better, both for the structure and the facade. And when we do that, is also because we want to look at the interior. So here we are able to visualize all the residential units inside. This was a building for students. So those units are well set with a certain amount of square meters. So these units inside, they were auto-generated, and we could immediately understand how many we would be, like if we were meeting that target, and also which one would be then the wasted area or the dark area where it would be better to locate the core. So it is also easier to grasp if a certain decision actually it's meeting our targets, and if it makes sense, and how to change it. And as I said, when we do that is also because we can then easily generate some walls and run daylight simulations for the interior, understanding if the facade that we want to create is actually working also internally. Really a lot of data kept in consideration. If, for example, in this case, we are looking at the carbon footprint. So we actually have, in this case, not a complex script, but a very complex Excel that our head of sustainability built with plenty of data. Here you can see just a tiny bit of that. But what we do is we utilize Grasshopper to auto-generate the slabs and a placeholder facade. And then it doesn't matter what the shape is, in just a click, we are able to bring it through Excel and then generate a lot of nice and clear diagrams that can help people to communicate to each other and understand better why a certain decision might be better than another. And again, we don't work only with architecture. So again, we are tracing back to Volkspark, to the project I was presenting. These are buildings on a large scale, and also for that, we are able to look into the carbon footprint, and the same for the landscape. So this is truly a way, as much as possible and as early as possible, to keep many data in consideration and make sure, especially when we are shaping cities, that we do that as best. Because, oh, Jesus Christ, this. Okay, this is the last one, like you. But so we know and we believe in as an office that all the big decisions should be taken on uh, early on when we have the most power as designers. So we don't want to just pick materials or to work with the small details. But if you truly want to uh, fulfill all the goals that you are having in terms of, for example, sustainability, then you should make sure that you do that as early as possible. All right. So I think that's all from my side, and we can maybe take some time for like questions. I don't have much time because I'm very soon likely going on Christmas holidays. So I have a lot of like external wishes to a lot of things to deliver on projects. So let's try to just take a few questions maybe.
Thank you, Eliana. The presentation has
Welcome.
been great. Many questions and many people saying thanks and very impressed by the presentation. Yeah, I'm not sure how to organize the questions because there are so many. I will try to just pick, as you said, a few of them. For example, the first one was if beside Rhino, what other BIM software application did you use? You show Revit, but I'm not sure if you use,
Okay, so
or maybe if you can complete it also with the plugins that you use for Grasshopper, because there are also some questions about that.
yeah, so so I mean, I think one thing you need to know. So in Denmark, we have a specialized figure for construction architects.
Mhm.
And here at the office, we have a lot of people that work in that phase. They use Revit. So in the early phases, we use Rhino, then we shift into Revit. We are also experiencing lately that we need many times to also look into ArchiCAD. But at the office, we don't use it. That's sometimes needed for collaborations, but our favorite is definitely Rabbit. And for, I mean, we use different solutions for transitioning from one to another. Not only Rhino Inside, we also use Speckle. In this specific case, Rhino Inside would work much better because we needed truly a lot of precision, control, and a lot of attributes to attach.
Thanks. Yes. That was
Maybe
a-
as other softwares I can mention, we also have in-house visualization team. They use
Mhm.
3ds Max as and then we have also a model shop and our landscape architects they use a lot AutoCAD um, and there is this plugin called Lemfia. So actually that's quite good because we can take all their quotes and then with the Grasshopper we can read the numbers and auto generate terrains from those quotes.
Yeah, thank you. Yeah, I was asking for the plugins because someone was asking about the slide that you show, Ladybug.
Yeah.
She was asking if it was a plugin or I think it was your own script, your custom script that integrates Ladybug tools.
Yeah. We integrate Ladybug tool. Like, I mean, mm, usually what I like is creating an interface where people can perform different things, so they don't need to switch from one script to another. And I mean, I just find that it's easier for people to then keep together a lot of information. Otherwise, when you switch to one to another, you might miss on something. So usually there is all the part of like simplifying complexity, auto-generating, maybe a very simple facade that then Ladybug actually likes, because if you're able to truly clean the geometry well, also just within Grasshopper, then I mean, you can run simulations really, really fast. And that is something I believe that is needed. I want to just do a small parenthesis. We also use Forma in the office. So we prefer it depends what we need to do. So if we need to be extremely precise and use data to shape things, to run optimizations, to do facades, I mean, then definitely Ladybug is our way to go.
Yeah, thank you. So just the last one, I think, because there are many, some people is also answering the questions in the chat. I saw one here from Antonio's that was Antonio Sauces that was asking how long it took to build this workflow in Cobe with computational design and all your scripts and how you share them in the office.
Okay, well,
Yeah, I know it's complex one.
I mean, we
Mm.
started very little, step by step, and honestly, I think when I joined, I had different goals compared to where I am today, because I kept myself very open. So one thing I like, even if I'm a huge nerd, it's to understand what people need. So I actually spend a lot of time kind of looking at how people work, um, what kind of repetitive actions they do, what kind of project Kobe specifically deals with. And I mean, actually, the tools are always expanding in a sense that, for example, maybe we create one script for one project and there are certain XYZ things needed, then and we learn certain things from this project. What I usually do is to make sure that this script is as flexible as possible. So if we are starting with a massing, I want the script to work for any massing. That means that if we need to extract the same information or run the same simulations for another project, I can utilize that script again. And maybe in the next project, you learn other stuff, new things, and then you make that same script grow.
Mhm.
So actually, a lot of things has been coming during the time and with the different requests from clients and also honestly from people, because when you take the time of also bringing on boards people that are non-experts, that maybe are even scared of the grasshopper spaghetti, then I mean, it's the most powerful thing you can do, because they are gonna be honest with you. If they are not using it, it means, I mean, honestly, maybe the interface wasn't good enough or it wasn't fast enough. So when they actually utilize it, then they can, I mean, they get very excited and they come out with a lot of new requests. So I mean, I have this open door policy, so I don't get projects from the management. It's actually people at the company that come to me with requests, and this wasn't true at the beginning. It became this way as soon as people started to understand. They could just come by with new ideas, and sometimes some people have their own with their own interface, and that tool is growing with them. It doesn't mean that the script behind the grasshopper part is different, maybe only the interface is.
Thank you. Yes, that's very, very interesting. Yeah, there are many more questions. People keep asking. I'm sorry for not being able to answer, but I don't want to steal more time from you.
Yeah, you're great, and it was great. And if people have question, actually, I always say this, I'm not great at LinkedIn. So if you text me there, I'll never reply or after many months. So if you really have like a question or you want to get in touch, my favorite is actually Instagram. So I'm very open if you're curious to just, text me and thank you so much for joining. It's really been a pleasure.
Thank you so
Thank you.
much. The presentation has been great. I am
Thank
really
you.
thankful.